the small generator which we have for our housing society. This is the electrical side of it now. So on the display, some information. These are the battery voltages now. Total starts 1715. This is the counter. 1284.5 was the counter of the running hours. No remote charge signal because it was under maintenance now. So it has been, that is like the safety. So like before maintenance, you put it on that mode so that it does not start right now when there's like a power failure. Like a 66% fuel in the tank. Of course, it comes from that kind of sensor. And then this is the engine temperature. Right, so there's this control on off, breaker on off, emergency stop. This is like a thing which should not be pressed unless it's required. And when you do press it, you see the arrows on this, but you see it becomes like an arrow in one direction. So you have to like twist it in that direction, and then it sort of depresses itself. When you press it, it get like, like goes in, and when you do that, then it will like jump out. If there's some alarm, you press this to acknowledge it. Manual is, you press the manual button if you want to start it. So in this moment, if I want to start it, I'll put on manual and I press start, it should start. Okay, so, and then of course there's one more emergency stop there. This will also do the same thing. Maybe there's just like a redundancy. Right, so then this is next to it. Here is the cable going from there and then coming here. And then this is again the main breaker. Auto, off, main. Okay, so there are three modes here. So when it's on auto, when it will be like a power cut, when the main is gone. So this will sense that the mains are off or there is no voltage on the mains. With that, when it senses that there's no power on the mains, it's gonna give the signal to the emergency generator that there is no power on the mains, so start up. So it's gonna start up, rev up, go to this rated RPM, which is 1500 for this. It was mentioned on one of these plates on the engine, so it's like 1500 RPM. And then it sort of like stabilizes at that, and then it connects. When it connects, it starts supplying to all the consumers. Where are the consumers? So this is all connected again, and it goes this feeder section. So this is all the individual consumers. So you see the clubhouse. I mean, someone has taken some effort and mentioned it. So if there is one section of the society which is not getting power, then you only open that and then you sort of troubleshoot there. So when it is in auto, all this will happen by itself. It will start up, rev up, start supplying, and then boom, everything is done by itself. For whatever reason, when you want to work on it, you put from 1 to 0, that is off. So in that moment, if there's a power cut, nothing will happen, and it will like not do any work in that moment, and you can like easily work on it. It's like safety during working. Mode 2 is manual. So manual is again then like when it has, for whatever reason, I mean auto, everything should work by itself, but if for whatever reason some component is not working, then it will not start up by itself. In that case, you can come to manual and then you can press start, and then also it will just start. Engine controls switch on off, so it's on now, phase. So when it is running, I guess there will be like voltage, ampere and hertz. This is the time which is taken in the first 10 seconds. So like for example, when we say that there is no power, DC will start within 10 seconds or 30 seconds. During that time, this is what is happening. So engine is starting from 0 RPM to 1500 RPM, and then it reaches this voltage where it stabilizes that the frequency should match with our frequency on the like the switch put at home. Earth leakage is like when there's a fault, there's a leakage current. I guess it's gonna tell you the value of it when there can be some fault. So all these things, like the MCCB or any switch, something, they have their inbuilt system. So like for example, this, it has already a system where it will prevent any like surge current or something like that. Just like we have these surge protectors in the house. So first the fuse will go, and what is this? Molded, yeah. So MCCB, molded case circuit breaker. That is, so in those cases, what will happen is it will trip the breaker. So, and by doing that, it will cut off the surge current supply. So what it does is it prevents your consumers. I mean, all the electrical system which is on the connection, that will be saved because it has cut down this current right here. In those cases, what you will see is this breaker, instead of being, now it's on. So you can see on. When it's on off, this thing will be down, and you will see off written on it. I mean, also there are like these markings up and down. So it's an on position item. But for the trip, it's in between. If you see 1, I don't know if you can see. So there's 1 here, 0 here. So that is this mathematical 0 and 1 that is on and off. And this triangle is the trip position. So when it's on trip, that means something has gone wrong. It could be a short, it could be just like a overload, but it has trip. So ideally in those cases, you must first see what has caused the trip to sort of like figure it out, whether it's like a problem or It could be a short circuit, in which case if you try to start it again, then maybe this can fail, and then it will not be protecting your. When it is in trip condition, the breaker is down, you cannot switch it on directly, because when you switch it on, there's like a spring inside, it will prevent from starting. So in that case, what you can do is, when it is on trip, you must first off it and then on it. So when you put it on off, everything gets reset, and then you switch on, and then it starts supplying normally. And in that case, again, if the fault still exists, whatever it is, the leakage current or surge or some short circuit, then it will trip again. In that case, then you must call an electrician, try to figure out really what is going on. These are all like other breakers which are here. These are all like individual breakers, so you can switch on and off. It could also be like one of these breakers are tripping for whatever reason. And you can again do the same thing. So right now it's all on. If it's tripping, it will be in some center position. So you have to like off it and then on it. These are the line voltage sensors. This is what tells the generator to start. So when now is on means the electricity is there from the mains, and when these go off, it will be like, okay, generator, there's no main power, so you must start now. It is what it means. This is most probably the cable which is coming from there and carrying the signal and telling the emergency generator that, okay, you know what, there's no power, so you must start now. And then it starts, and then it does that, like going up in speed, stabilizing, and then connects to the bus bar, and then after connection it starts supplying. This was like a short something about the electrical stuff. Regarding the mechanical stuff, it's in another video, but this was like some basic things. I mean, this is same, like any breaker in the house also is the same. So if you need to like off it, you off it. If it trips, you off and on it. Emergency stop, if it's pressing, you must like sort of release it before you can operate it, otherwise the engine will not work. It's like a mechanism which will prevent accidental startup. And then here is again, these are important, so it should be on auto, right? So this was a little bit talk about the electrical side.
Hey there, thank you so much for watching. In case you liked the video, please do subscribe. Also, if there's a comment or any feedback or a question that you have about the video, please do post below. Thank you.